Valid anagram. Given two strings s and t, return true if t is an anagram of s and return false otherwise. An anagram is a word or a phrase formed by rearranging the letters of different words or phrases using all the original letters exactly once. Here in this case, A comes here, N goes here, A goes here, G goes here, R, A and M remain same. So these two are a valid anagram. In this case, rat and car cannot be made with rearranging each other's alphabets, so we return false. So one way to solve this question is to sort both the letters here and see if the values are the same or not. So when we sort this anagram, we get this, and we sort nagaram, we get this, which are exactly same. So we say it's an invalid anagram. When we sort rat, we get art, and when we sort car, we get ACR, which are not equal, so we can say that this is not a valid anagram. So for the sorting method, the time complexity will be O of n log n and the space complexity will be O of 1. So what we did here is to sort the first string and then sort the second string and check if s is equal to t, then we return true that it's a valid anagram, else we return false. So a better way to solve this question will be to use a hash map. So we create a frequency array of size 26 to store every single alphabet. So in this array, 0 will be corresponding to A, 1 will be corresponding to B, 2 will be corresponding to C, and so on for all the 26 characters of alphabets. So what we will do is we will traverse on this array of characters first and increment every single character's count by 1. First we reach A, so we increment count as 1. So initialize this complete array with 0, so every single element here will be initialized with 0. So by reaching A we have 1, when we reach to N we increase the count to 1. When we reach A, we get this count to 2. When we reach G, we increase the count of G to 1. R, like that, 1. Then we go to A. Then we increase the count to 3. So then for M, we get the count as 1. And like that, the rest of the array element remains 0. After that, what we will do is we traverse this array, and for every character we see, we will decrement the count of this array by 1. So we reach n, then we make it 0. Then when we reach a, we will decrement this count, so 3 will become 2. Then we go to g, g is 1, so it will become 0. When we go to a, this 2 will become 1. And when we reach r, this will become 0. When we reach a again, this 1 will become 0. Then when we reach to m, this 1 will become 0. So at the end, if the entire array is 0, then we can say that these two strings are a valid anagram. So let's look at the example number 2. So here we traverse the string first. For r, we increment this value by 1. Then for a, we increment this value by 1. For t, we increment this value by 1. Now, when we traverse the second string, we decrement this value by 1. So this becomes minus 1. We decrement this value by 1. So this becomes 0. And then we decrement this value by 1. So this becomes 0. So then we traverse this entire array and we see any element that is a non-zero element. For example, by traversing we reach C, we see this minus 1 is not equal to the 0 that we wanted. So we say that this is not a valid anagram and we return false. So we can add an initial condition here that if the first string, the length of the first string, here in this case 7, is not equal to the length of the second string, here in this case 5, it can directly return false, because then it will never be an anagram. So now, how will we increment the frequency of the character here? So we know that the ASCII value of these characters, that A is 97, B is 98, C is 99, and so on. So what we can do is, just while incrementing, we can do the character minus the A value. For example, let's say the character is C here. So the ASCII value of C is 99. Now, if we subtract the value of A, that is here in this case it's 97, it will always be 97, that will be 2. So on the second index, it will increment or decrement the value of C. There is also an alternative. If you don't want to make a array of size 26, you can directly create an array of size 256. In that case, you don't have to do that character minus a thing here, but rather than using 256 array, as we know that it will always be a lowercase English letters, so in this case we can just create an array of 26, but then you have to take care while incrementing or decrementing the value that you have to subtract it with a. And always remember that we always have to initialize the entire array with 0 to check for the later conditions. So the time complexity for this method will be O of n, as we are traversing every single string only once, and the space complexity will be O of 1, as we are only creating a constant size array of size 26, or say 256 in any case you want. And in case you are using an unordered map, then the space complexity will be turned to O of n, because an unordered map will take a space complexity of O of n, or the number of elements in that string. So initially we are checking if the length of s is not equal to length of t, then we can directly return false. Else we can create an array of frequencies that will store the frequency of each element of size 26, and then traverse on the first string s, and increment every frequency of each character by 1, and then we traverse into t and then decrement the frequency, and then we traverse the frequency array, and if we find any element to be not equal to 0, then we return false, or if we can come out of that loop, we can return 2.